Let's do lesson 7.4 on simplifying expressions with rational exponents. All right, this is some good stuff. All right, let's look at our first couple of examples. We want to simplify expressions with rational exponents. So a rational exponent, rational is just another word for a fraction. Okay, so we just have fractions in the exponent, just like this. But remember, I said this is kind of like a tree. So we can think of that 1/3 as a tree. Here's the root, and here's the power. Okay, so this is really, if we want to write it as a radical, it's 64 to the first power, and I want the cube root of it. We've done these before. We can do these. So we just want to split 64 into 3 parts that are exactly the same. So let's see what we can do. I'm going to do 4 and 16. And then I'm going to do 16 into 4 and 4. And look at that. I have 4 cubed. So I can rewrite 64 as 4 cubed, and make sure that you have the right index on here, because what I've noticed on quite a few of your papers is that all of a sudden we go from the cube root to the square root just because we've forgotten to write the index. So make sure that you write this. So we're going to simplify this now. We've done this before. Anything in the parentheses we're going to take out because this cube and this cube root cancel each other out, and we're left with just. Let's take a look at the second one. This time we're multiplying these. Remember, we've looked at this before. In order to be able to multiply these together, they have to have the same base. In this case, 7 is the base. So they have the same base. And when we do that, when we multiply this times this, we actually add the exponents. So what we end up with is 7 to the 1/2 plus 1/2. Well, what's a half plus a half? It's just 1, or 7 to the first power. Any number to the first power is just that number, so our answer here is 7. All right, let's step up our game a little bit. This time we have 5 to the 1/3 times 25 to the 1/3. And you are saying, well, Ms. Harmeyer, we can't do those because they don't have the same base. But we can try to turn these into the same base. Let's look at this 25. We know that 25 is just 5 squared. So let's rewrite it that way. So we end up here, we've got 5 to the 1/3 times, I'm going to rewrite 25 as 5 squared. That's the same thing as 25, and that's raised to the 1/3 power. Well, what happens when I raise a power to a power? I just multiply them. So 2 over 1 times 1 over 3 just becomes 5 to the 2 over 3. 2 times 1 is 2. 1 times 3 is 3. And let's not forget this first part. We've got 5 to the 1/3. Now this looks very similar to this problem we just did. They have the same base, so we just add the exponents. And this becomes 5 to the 1/3 plus 2/3. 1/3 plus 2/3 is 1, so this ends up being just 5. All right, I want you to try these 3 quick checks right here. They're very similar to the 3 problems that we just did, almost identical. So turn this into a radical. You know what to do with these. They have the same base, and then make these have the same base. When you're done, come on back. All right, now that you've finished the quick checks, let's look at converting from radical form to, let's look at converting from rational form to radical form. So this is a rational exponent. I just want to turn it into a radical. Remember, this 2 over 7, if we think of our tree, here's the roots, and here's the power. Okay, so this is x to the second power and the 7th root. That's how we would write it. This is in rational exponent form. This is in radical form. There's our radical, the 7th root. Let's do this one. Let's take a look and see if we can simplify this negative exponent. So this is negative 0.4. I want to write this as a fraction. Well, 0.4 is the same as 4 over 10. And I can reduce this, divide both the numerator and the denominator by 2, and I get negative 2 over 5. All right, well, here is my root. Here's my power. So we can write this as y to the negative 2 and the 5th root. There's one last thing. So this negative exponent, we dealt with this quite a bit in Algebra 1 and a little bit at the beginning of Algebra 2. That negative exponent just means that this is not happy where it is. So if it's a negative in the numerator, we're going to move it down to the denominator. So this is going to become the 5th root of 1 over y squared. So all we did was change this exponent from the numerator into the denominator, and we made it positive. Take a look at this quick check and try that one out. All right, we went from rational to radical form. Now we're going to go from radical to rational. So look at this. Here's our power. Here's our root. So we know that this is going to be 3 divided by 4. So it's just c to the 3 over 4 power. Here we had the power on the inside and the radical on the outside. We can write the same thing with the radical on the inside of our parentheses and the exponent on the outside. So this is still the 5th power and the 3rd root. So it would be b to the 5th power and the 3rd root, or b to the 5 over 3. So now you can do this second quick check right here.